What if you're factoring special cases? There's no real way around it. You just have to memorize the patterns. So first of all, let's talk about why these are called difference of squares, sum of cubes, and difference of cubes. If you recall, difference means subtraction. So difference of squares means that you're subtracting perfect squares. A difference of cubes means you're subtracting perfect cubes. And sum of cubes means you're adding perfect cubes. Okay, now the way that we would actually factor this is for a difference of squares, you would take the square root of the first term, and that gives you a, and the square root of the second term, and that gives you b, and you basically have it twice, the a and the b. The difference is that one would be a plus and the other one would be a minus, and it doesn't really matter which one is which because the order in which you multiply things doesn't matter. So like if you have 3 times 5 or 5 times 3, you get the same answer. So for sum of cubes, it's a similar thing. You would cube root the a, cube root the b, and for this, the signs do matter. So if it's a sum, then your first term, your first factor will be a sum. And then your second factor will be the opposite sign. Okay, that's how I remember the difference between sum of cubes and difference of cubes. Because for the difference of cubes, if you start off with a minus, then your first factor will be a minus, and then your second factor will be the opposite sign. So for example, if you have x to the 6 minus 25, the first thing you should notice is probably the number, the 25, because that'll tell you if we're looking at a difference of squares, sum of cubes, or difference of cubes. Because 25 is a perfect square, but it's not a perfect cube, we know that we're going to be using difference of squares. Okay, and for variables, what we're looking for is that the exponent is an even number, because taking the square root of a variable basically means dividing the exponent by 2. So because it's a difference of squares, the way we factor it is square root the first one, so that gives you x cubed. Square root the second one, which gives you 5. And again, you have it twice. You have x cubed and 5. And one of them is going to be a plus, one of them is going to be a minus. And again, it doesn't matter which one is which, as long as you have one of each. Okay, what if you have 8x cubed plus 27? Again, focus on the number first. 27 is a perfect cube, but it's not a perfect square. So we know that we're going to be working with sum of cubes. So you cube root the first term, and you can do it separately. So cube root of 8 is 2, and cube root of x cubed is just x. And cube root the second term, which is 3. And because this is a plus, our first term is going to be a plus. Then for the second part, square the first one, so 4x squared. Then because this was a plus, our second one's going to be a minus. These two multiply together, so 6x, and then this one squared, so plus 9. And that's how we would factor special cases.